Hello children. Today let us discuss some programs. Okay. So see the first program to check or to find factorial of a given number. Okay. See here number is equal to int input enter a number. Okay. So you can enter one number. That number is read into the variable number. Then n comma result. Here we have two variables. Okay, both are initialized together. Okay, n comma result is equal to number comma 1. So this number will assign to n and 1 will assign to result. Okay, then while n greater than equal to 1. Okay, result is equal to result into n. Okay, suppose our number is 5. Then what will happen? Now n is equal to 5. Okay. Then n greater than equal to 1, condition satisfied. So result is equal to 1 into 5. So n is equal to n minus 1. So here n will be 4. Then on next iteration n greater than equal to 1, condition satisfied, because now the value of n is equal to 4. The result is equal to result into n. Now the value of result is equal to 5. Then 5 into 4, 20. Result will be 20. N is equal to n minus 1. So n will be 3. Then next iteration 20 into 3. Then n is equal to 2. Next iteration, what will happen? Yes, 60 into 2. Okay, then next iteration n will be 1. Then 120 into 1. Okay, next iteration n will be 0. So this condition failed. N greater than equal to 1, condition failed. So it will assign this result into the variable factorial and print the factorial of number is factorial. See, first factorial of is given in between double quotes. So whatever you given in between double quotes, that will be print in your screen. Then for number here, no quotation. So the value that is stored in this variable will be printed. Then is in quotation. So is will print on screen. Then factorial, no quotation. So the value that is stored in this variable factorial will print. Okay. So let us check the output. Now run the program. So here enter a number. Here I am giving the same number 5. Okay. So you will get factorial of 5 is 120. Clear children? Okay. So let's move to next program. See, our next program is Armstrong number. Okay. Program to check whether the given number is Armstrong or not. Then what is meant by Armstrong number? Yes. Armstrong number means the cube of the sum of cubes of the digits is equal to the same number. Then it will call as Armstrong number. For example, 153. Okay, 153 is an example for Armstrong number. That means 1 cube plus 5 cube plus 3 cube is equal to 153. Okay, so let us check how to do the program. Num is equal to int input enter a 3-digit number. The 3-digit number is stored into the variable num. Sum is initialized as 0. Temp is equal to num. Okay, the temporary variable is referring to the variable num. Then while temp greater than 0, digit is equal to temp mod 10. Temp mod 10. Suppose our number is 153. Then 153 mod 10 will give the answer 3. Okay. So sum plus equal to digit into double star into 3 means cube. 3 cube will do. Okay. That is 3 into 3 into 3 into 3 into 3 into 3, that will add into the variable sum. Initially sum is equal to 0. Okay. Then temp floor division is equal to 10. Floor division means it will take the quotient. So 153 floor division floor division by 10 will give the answer 53. So now the value of temp is equal to 53. Again temp mod 10. Okay. So here, temp floor division 10 will give 150, not 53, because our number is 153. Okay, so it will give 15. Then temp mod 10 will give 5. Okay, then 5q will do. Okay, like that this loop will execute. Okay, after executing all, then it will check whether this num is equivalent to sum. Okay, when this condition is satisfied, it print num is an Armstrong number. Otherwise, it print num is not an Armstrong number. Now let us check what will be the output. See here, enter a 3-digit number. Okay, here I am giving 153. Okay, here I am giving 153. Okay, so 153 is an Armstrong number. Okay, I will give another number. Again run the program. Okay, here I am giving 122. See, 122 is not an Armstrong number. Okay, children. So next program. Okay, our next program is perfect. Okay, we can check whether the given number is perfect or not. Okay, a perfect number means the sum of the divisors is equal to the same number. Then we can say that that number is a perfect number. Okay, so for example, number 6. Okay, the divisors of number 6 are 1, 2, 3. Okay, then 1 plus 2, 3, 3 plus 3, 6. Okay, 6 is equal to 6. So we can say that 6 is an example for a perfect number. Okay, so here n is equal to int input enter a number. So here you can give a number. Sum is equal to 0. For I in range 1, n. Okay, then if n mod I is equivalent to 0, that condition means this condition is used to check whether I is a divisor of this variable n. Okay, if the condition is satisfied, that divisor will add into the variable sum. Okay, so after doing this loop, we will get all the divisors and sum of the divisors. Okay, sum of divisors is in sum. Then we can check whether sum is equivalent to n. If the condition is satisfied, print number n is a perfect number, else print the number is not a perfect number. Okay, so let us check the output. What will be the output? See here, run the output. Here we can give a number 6. Okay, so the number 6 is a perfect number. I am giving another example. Here I am giving number 12. Okay, so 12 is not a perfect number. Okay, children. Then next we can do another program. Okay, that one is called Palindrome. See, program to check whether the given number is palindrome or not. Okay, so first we read one number into a variable num, then w num is equal to num. That is working number stores num initially. W num is a working number. REV is equal to 0. Then children, do you know what is meant by palindrome? Palindrome means a number and its reverse is equals. Then we can say that that number is a palindrome. For example, 121. 121 and its reverse is also 121. So 121 is a palindrome number. Okay. So here this loop, while w num greater than 0, dig is equal to w num mod 10. So we get last number. For example, 121, we get 1. Okay. Then REV is equal to REV into 10 plus digit. So initially REV is equal to 0. So 0 into 10 means 0 plus dig is equal to 1. So initially REV is equal to 1. Then W num floor divisible by 10 means it will get 12. Then on next iteration, 12 mod 10 will get 2. Okay. Then REV is equal to REV into 10. That is 1 into 10 plus 2. So we get 12. Okay. Then W num is equal to W num floor division 10. So 12 floor division 10 will give 1. Again 1 mod 10 will give 1. Okay. Then here 12 into 10 120 plus 1, 121. Okay, again this floor division by 10 will give 0. So this condition will failed. Then it will check 121 is equivalent to 121. That is num is equivalent to num. REV. Then if the condition is satisfied, it print num is a palindrome. Otherwise print num is not a palindrome. See children, when I give this program, you have to note down the indentation of each line. See, these are the block lines, block statement. So after this column, see, these 3 lines are in the same level. Okay, so this while loop is over. So the next line is again started from here. Here again block statement. So it will indented. Okay, then after that, this one is over. So else is again start from here, not from here. Okay, so by writing this program, you have to note down the indentation also. Okay, so let us check what will be the output. Same here, you can give a number. Here I am giving 123. So 123 is not a palindrome because the reverse of this 123 is 321. Okay, so it is not a palindrome. Let us take one more example. Here I am giving 121. So 121 is a palindrome because 121 and its reverse is same. So this one is a palindrome number. Okay children. So now I believe you all have understood all the program that I discussed today. Okay, we have to discuss so many program. That program I given in your notes. You have to copy that notes into a notebook. Don't forget to copy these notes into your notebook and also study and try to do the same programs in your systems. Okay, see you again in another section. Till then, bye. Thank you.